Hello, and welcome to the Demoette series for TIBCO Data Virtualization, or TDV. Demoettes are brief instructional videos that demonstrate specific features of TDV. In this Demoette, we discuss TDV, cache policies. Here is our agenda. We begin by defining cache policies and outlining their importance for our customers. Next, we walk through a very basic demo of cache policies. Finally, we summarize the contents of this Demoette. Let's begin by discussing what cache policies are and why they are important for our customers. Cache policies specify cache refresh and expiration schedules for user-defined groups of cached resources. When data consistency is required across multiple cached resources, policies ensure that caches contain data that has been refreshed at the same time. In addition, if a refresh operation for one resource fails, all caches are rolled back to the last successful snapshot of data. Policies can also enhance the performance of cache refreshes because TDV considers dependency relationships across multiple cached resources and schedules the sequence of refresh operations accordingly. Because of the all-or-nothing nature of policy-based cache refreshes, policies and incremental caching are not supported for use together. Cache policies are important to our customers in many use cases. Policies are an important tool for enhancing data consistency across multiple caches. They can also ensure accuracy and efficiency when dependent cache refreshes must be scheduled. Next, let's walk through a very basic demo of cache policies. Here is the business problem that we illustrate in this demo. This enterprise has many use cases that require data from three physical data sources: sale, order, and supplier. The enterprise has chosen to cache these data sources in TDV. In addition, TDV developers have created a federated view that uses data from all three cached tables. This view is also cached. We'll show how cache policies can enhance the consistency of data across all caches and how it can also enhance the efficiency of the refresh process. As a prerequisite to this demo, you must have a working knowledge of both single-table and multi-table caching. If you need a refresher, there are demoettes available on both of these topics. This demo requires data sources, a cache target, caches, views, and procedures. We'll take a closer look at each of these. Users may import these resources from the Demoette repository. To build the data sources for this demo, I started with View Order, View Sales, and View Supplier from the TDV Studio Examples folder. In the Result tab for each view, I used the Save button to write data to a CSV file. I then opened the CSV files and saved them as Excel workbooks. Finally, I introspected each workbook as a separate data source. We can now demonstrate a cache policy that works against multiple data sources. In addition, Excel makes it very easy to add new rows to the data and see those rows in cache refreshes as part of the demo. Next, I defined a cache target database and set up its status and tracking tables. I used MySQL, but of course you can use any supported cache target. I defined simple views that look exactly like the physical tables, and I used single table caching to cache each view to the cache target database. You can choose to cache the actual tables instead, but I found it convenient to use views so I could easily examine caching behavior by looking at the view's execution plan. I also created this federated view that joins all three tables. Again, I used single table caching to cache this higher level view. Finally, I created two very simple procedures, which are shown here. Now we are ready to begin our demo. As noted earlier, we have already set up single table caching on all of the views we will be using. Our goal is to use a cache policy to ensure that all these caches remain consistent with one another. In the Studio namespace, open the server, then open Policy, and right-click Cache. Select New Cache Policy. Name the policy. On the Resources tab, drag each of our views into the Resources pane. Now move to the Cache Policy Settings tab. Enable the policy. Set storage to user-defined, then browse and select our cache target. We'll use manual refresh mode because that is most convenient for a demo. Save your work and click Refresh Now. The cache status changes to up. All 4 of our caches have been refreshed. You can verify the start and end times of all the refreshes by opening the cache status table. You can check the fetch statement in the execution plan on any of our views to verify that the data is coming from the cache. Now let's simulate an error condition and see how a cache policy behaves. First, add a row to each data source so that we'll have data to examine for freshness. In the order table, add a row with an order ID of 999 and a product ID of 888. In the sale table, add a row with a product ID of 888. In the supplier table, add a row with a product ID of 888 and a transaction ID of 777. Save your work. Next, disable the order database and save. This will make a cache refresh on the order database impossible. Open the policy and click Refresh Now. The refresh operation returns an error, and the order view does not show the new row, which is the expected behavior. Note, however, that the new data is also missing from the sale, supplier, and federated views. That's because our cache policy ensures that success or failure of cache refresh operations is all or nothing. Now re-enable the order database and save. Open the policy and click Refresh Now. The latest data now appears in every view covered by the policy because all caches were able to refresh successfully. Next, let's examine pre- and post-refresh actions. In the Advanced panel of the Cache Policy Settings tab of the policy, you can specify procedures to be executed before and after the refresh takes place. The procedures used in this demo are extremely simple. The pre-refresh procedure writes a start message to the server log, and the post-refresh procedure logs a finish message. Refresh the policy, and we see the results of each procedure in the TDV server log. We can learn more, though, by adding these procedures to each view in the policy. Go to each of the 4 views in our policy and add the procedures there as well. Now the log will help us understand how cache policies deal with dependencies among caches. In between the start and finish of the overall policy, the Level 1 view refreshes are started immediately and run simultaneously to completion. However, the federated view refresh is not started until all the Level 1 refreshes have finished. That's because TDV understands that the federated view depends on the caches of the Level 1 views. TDV automatically schedules the proper order of execution for all refreshes in the policy. This enhances processing efficiency and data consistency. Finally, let's look at another important feature of cache policies. It is possible to mix single-table and multi-table caches within a single policy. Go to the federated view and change its caching to multi-table as shown here. Click Create Cache Table and the DDL is created. Execute it and save. the cache status changes to not loaded. Now open the policy and refresh. The status changes to up. As the federated view execution plan shows, data is now being retrieved from one of the multi-table cache tables we defined. Cache policies can use single-table caching, multi-table caching, or a mix of both. We have seen how to define cache policies and examine their behavior in both success and failure scenarios. We have looked at pre- and post-refresh procedures and seen how TDV automatically deals with cache dependencies in policies. We have also seen how a single policy can mix both single-table and multi-table caching. Our demo is complete. Let's summarize what we have seen in this presentation. Cache policies specify cache refresh and expiration schedules for user-defined groups of cached resources. When data consistency is required across multiple cached resources, policies ensure that caches contain data that has been refreshed at the same time. In addition, if a refresh operation for one resource fails, all caches are rolled back to the last successful snapshot of data. Policies can also enhance the performance of cache refreshes because TDV considers dependency relationships across multiple cached resources and schedules the sequence of refresh operations accordingly. Because of the all-or-nothing nature of policy-based cache refreshes, policies and incremental caching are not supported for use together. Cache policies are important to our customers in many use cases. Policies are an important tool for enhancing data consistency across multiple caches. They can also ensure accuracy and efficiency when dependent cache refreshes must be scheduled. Thank you.